Uh, how you going, everyone? This here is a Xceed EX25MT multi-tool. And I bought this thing in about 10 or more years ago. I bought this for a very specific job. Um, Basically, sort of what I wanted to do was to attach a thinner piece of timber to a thicker piece of timber, and I needed to make a very specific cut into the timber where I had to come halfway down in this direction and then halfway in this other direction. Um, and I could do this by using some, saws and chisels and stuff like that, but I didn't have the skills or even the patience to do that sort of thing at the time, nor did I have the actual, chisels in order to do that. And so it was, in my mind, it was easier and more cost effective to get one of these things. And just to show you exactly what is possible with these things, all of this here was cut with a multi-tool. The problem is that when I bought this thing, about shortly afterwards, the interface of these had changed very drastically, which meant that the tooling for these, which was based off of the let me just move that a little bit, which was based off of the original Renovator, was no longer compatible with new tools, with newer attachments and whatnot. So for all of the newer developments in the oscillating multi-tool range, with things like bimetal and carbide blades, tools for grouting and circular sanding pads and discs and the like, you couldn't do that with one of these. You could only really use whatever tools and attachments were available at the time. However, quite recently I got this, does that one fit? Yep, okay. Quite recently I got this sanding finger here. This is a Works sanding finger. It pretty well looks almost exactly the same as all the others. Just bear in mind, just a tip, I should say, these sanding fingers don't like to run as quickly as the sanding triangles. So whatever speed you'd run one of these ones isn't the same speed as this one. If you try, the sanding fingers will melt quite quickly. These guys, you run at a much lower speed. But anyway, this Works sanding finger came with this adapter here. You can get adapters online, and these are what they look like, right? But these here are made out of a cast material. They're very brittle. They don't work very well. And for something as purpose-built, you would think that it wouldn't be as good as an afterthought released by a budget tool platform. But if I remove this here, you can kind of see that this little piece of mild steel here has got these, these little 6 little buttons here and these 2 magnets on here, but it just sits so nicely on here, and it sits flush. And I've used this a little adapter for for a lot of things, and I haven't had any problems with it, unlike the purpose-built adapters. But before I got this sanding finger, I actually picked up this Rockwell oscillating multi-tool, and this Rockwell one, it has an updated interface, which works with the universal fitments, and I thought, well, I've got both of these, and both of them were $80, when I first bought them. And both of them, have a lot of similarities. You've got a cast aluminium gearbox here, glass fiber reinforced clamshell, TPE overmolding here. The switch up the top here with your variable speed trigger down the bottom. If we have a look here on the Xceed, very similar. Power switch up the top, variable speed trigger down the bottom, glass fiber reinforced clamshell with a TPE overmolding. This one here is a 250 watts, 10,000 to 21,000, and the Rockwell is 300 watts with variable speed from 15 to 22,000. And I thought in this video I'm going to do a partial teardown of both of these just to sort of show you the difference in quality between both of these budget tools, despite the fact that they were $80 when I bought them brand new. I've used both of these, and I have found that there are, a number of differences between the two. Nominally, I like the sound of the Xceed quite a bit better than the Rockwell. And the Rockwell, the blade tends to kind of vibrate a lot more than the Xceed, which is quite difficult to actually get into a tool, because rather than the blade going like this, it sort of goes in this direction too. So you get this sort of a scratching pattern before the blade can actually get it purchased into the material. So, I think I will start by showing you the brush housing and circuit boards in both of these tools. We'll start with the Xceed. I'll tell you what. So to do this, we've got 2 screws here. I want to do this by hand because I don't want to can these screws out. Do I have somewhere where I can put these? Yep. Okay. Taking these screws out will sort of separate this half of the 2 clamshells, and then this screw here is what you remove to expose the brush. Kind of need a knife to get in there. Could I use this? Why am I dropping everything? Wait, almost got it. Yes, okay. Yeah, so that there is, you can kind of see how it's marked there. And you can very plainly see the glass fibers in there. Sort of, these things sit so unbelievably snug in there that you've got to get them, perfectly in line and centered. And already you can kind of see just there, that's about, actually, let me just get a veneer caliper and we'll just, how am I to do this? That's about 0.9 of a millimeter, so we can say about 1 millimeter thick bronze, brush housing just there. Then we've got a clock watch spring just here, and then you've got this copper, this braided copper thing that comes off the brush housing just there, which then connects to the spade connector here, which then, you've got heat shrinked, sort of, that there's your, obviously your cable wiring just there. But we'll take these 2 screws out of here and we'll pop this half of the clamshell off. There's actually 2 halves. The other side looks exactly the same here, but I wanted to show you. Come Yes, there we go. I wonder why that was so stuck. That was weird. Let's see. Okay. Yeah, so there is your board is just there, and you've got these, are they, they're spade connectors. So these here, obviously, that there's your mains power, you've got your, that there's like capacitor, I think, you've got two little capacitors there, and then this is the cutest little thing. It's just like this little on and off switch, and that there is what's responsible for switching the thing on and off. So your switching mechanism isn't actually up here. There's like this glass fiber reinforced, sort of lever that kind of goes down there, and then that there is sort of your potentiometer. But this board here, is epoxied in there, so we can't actually sort of in everything, in these little like that adjustment doodad. I'm not entirely sure exactly what these are called, so I'm sure there are plenty of people who'd be looking at this going, it's called that. It's like, well, I don't know. I'm not savvy on electrics. But you can kind of see here the sort of like the brush, maybe you can, the kind of the brush housing is sort of, again, is sort of like this nice, robust, it's screwed into the sort of the main kind of casing just here. You can sort of see how all the dust kind of gets in there, but none of the dust ingress is going to affect the board because the entire thing is potted in place. Now you've got sort of good positive contact, with the brush. These are, these are pretty decent springs. But because this tool is discontinued, I don't exactly know how, the likelihood of finding a tool, finding brushes sort of that would actually fit this particular tool. But there's still a lot of material in there. Like I haven't used this thing very often, and there's, like I said, I've maybe only used about maybe 5% of the total. Not even 5%. I would say like a lot more than 5%. You can sort of see that, as I'd said, there's a lot of, the top of the brush housing is literally like 4 millimeters, and you've got, maybe 15 millimeters of this brass brush housing that goes right down to the commutator, down the bottom just there. And again, this thing is potted on the back, very similar sort of doodads on on the rest of it. But we'll put this back together, and I'll show you this. Actually, we'll go a little bit into the casement here, because you can sort of see, like, you've got these, these little anchor points there in the, sort of in the molding here, so like it doesn't actually peel off. I mean, I've had this thing for 10 years and it hasn't peeled off yet, so you can sort of see there, PA6 GF30. And then there's a little bit of markings just here. You can sort of see, sort of right there where they've had to do a little bit of repair work after the fact. And then you've got these two little pins here, which I don't exactly know what they would be. Would they just, there doesn't really seem to be anything that these two would actually line up with. Maybe they line up with something that I'm not seeing on the other side. But it's outside, it's sort of, there's a little bit of flexion there, but it's quite thick. But you've got these are strange. These are quite peculiar, these channels just down here. That would have taken quite a bit of work in order to, quite a bit of work, the machining process to get into there. Sorry, I'm just running off of stuff that AVE says. Arduino versus Evil. But yeah, no, sort of really interesting stuff. I wish I knew a little bit more about plastics engineering so I could say, but ooh, actually, that just kind of slid right in there. That didn't have any problems going in there at all. It's a fun fact about taking things apart is the joys of trying to figure out how they go back together. Now, I'm pretty sure these two are the ones that go in here. I hope this isn't boring for you guys. I tried looking up these Xceed EX25MTs online, and they're surprisingly not common. That's a peculiar thing with like these cheaper things, right? Because they're mass produced, right? They're mass produced along with the with the more expensive stuff. But you know, like with the Bosch and the Milwaukees and the Makitas and the Ryobis and all the other guys that were being made at the time that this was being sold, they would have been the big sellers along with the Renovator, right? But this guy here was sort of like at the top shelf, you know, or maybe, you know, sort of on the ground in the back there. You know, it was the cheapest thing. And when people are going out there and they're going to buy a brand new one of these things, they're not going to get the cheapest one. They're going to get the expensive one, or, you know, the best one that they could afford. But this at the time was the best one that I could afford. And going online and looking at these things, it's like everybody else is sort of, they got the best that they could afford, and it wasn't this thing. So there's almost nothing about these things. So, you know, even though like you go online to try and look for these things, you can really only get like 2 results, 3 maybe, of all of Google. I mean, think of all the billions of resources and, you know, the billions of websites and all of the places where, you know, all of the world's information is kind of compiled into this database that Google has created, you know, so it could be like the best. And this tool here, this budget tool, doesn't even, like, rarely gets a mention. So in like 25 years from now, this thing's going to be just so damn rare because, like I said, nobody would have bought them. So it's like the only ones that have survived are the ones that people have just kind of kept around, you know, for one reason or another. For me, it's because I genuinely like this tool. But yeah, okay, yep, that I'm hoping that kind of just slid in properly. See, when they built this thing, you know, all that time ago, like a decade ago, they didn't really understand the, you know, the tolerances of these things. So like they put a lot of effort into building the gearbox and the, you know, and the body, and they put a lot of effort into, you know, epoxying the boards and you know, so many things, you know, so the ingress of dust in this thing is almost completely mitigated. You know, of course you're going to get dust into the, like in here, but it's not going to become so much of a problem. Because the dust is going anywhere where it's not, you know, damaging the tool. But, you know, enough about that. If you want to know what the inside of the gearbox looks like, it's basically, you've got a bearing, and that bearing sort of, well, you've got the axle of the motor, and the end of the axle is sort of machined to offset. So as the motor axle is spinning, the end of the axle is sort of, you know, kind of going like this, right? And there's a little bearing on the end of there, which of course, you know, rotates like this, you know, sort of like, you know, it's kind of like kind of like a crankshaft, I suppose. It's sort of, yeah, just as the center point is rotating, the offset point is, you know, of course, going around its axis. And there's a fork which is attached, which is friction fit onto an axle, and on the end of the axle is of course the interface where your tool attachments goes onto, and that fork, as the bearing comes around, it hits the fork side to side, which causes the fork to oscillate from side to side, which of course then pivots on the axle point, which of course is what causes the oscillating motion in the interface. But enough about that. We'll have a look at the Rockwell tool. Now bear in mind, as I mentioned before, both of these tools were about $80. This thing here I only bought like a week ago. Maybe not even, maybe 4 days ago. It's very new. This is like, you know, very new 2020, 2021 sort of thing. Yeah, 2020, 52. The Rockwell RD5517. Of course, we all know Rockwell from their prefamulated turbo encabulator. And the prefamulated turbo encabulator, you know, was a revolutionary concept, revolutionary innovation. It really sort of redefined industry standards, you know, across multiple fields, and it really paved the way for further innovation in several fields. There's just so many that I can't really think of them all right now. And of course, from that point on, Rockwell had cemented itself as a company that prided itself in innovation. And this one here, I kind of find it sort of quite peculiar that the point at which because the airflow is obviously coming out from the end of the tool here, is just blowing out that way. And the fact that you've got this air vent just here that's pointing downwards, it means it's all the dust that's being created here is kind of just blowing around here, which while the air vent is on the bottom, or the suction, the air goes in here. Can't remember, I don't exactly know what to call it right now, but air comes in here, comes out there. You've got all this dust blowing around here. It's being sucked right back into there. The thing I liked about the Xceed is that the intake vents, that's what they're called, intake vents, were on the sides. So all the dust could happen here, and because they're on the sides, you're kind of reducing the amount of dust ingress through the design. And of course, being here, this is the point where you hold a good. Why would you put it there? I don't know, but we'll just kind of remove this, and right off the gates, it's a different thing altogether. Same thing here. You've got PA6, GF30. This thing is it's quite amazing just how much messing around they've done with this in order to get it to sit properly. Like, you've got all of these little, if you can see that, you can sort of see just these little goopy bits just down the sides here. I'm not entirely sure why they would put that there. And then why wouldn't they just kind of grind that off before? Because you can see around these injection pins here, because this is injection molded, because how this works is you've got two halves of a die, right? And they kind of clamp together, and then one of the dies has pins which injects plastic into it. And this glass fiber reinforced plastic is quite abrasive, so the more that you use a die, the more that it starts to wear out. And of course then you get this, the points there where you see, sort of you see the seam along where the two dies would have met together, and if they're not machined properly, or if they're worn out, you start to see you sort of see it on maybe cheaper screwdrivers, where on one of the sort of along the length there's sort of like a sharp protrusion that sort of runs down the length of the screwdriver handle, None of these screwdrivers have it, but I can't really find anything at the moment that actually has it. Maybe... No, not even that. Okay. But you've probably seen it around. Okay, yep, here. This old toothbrush. You can see that line just there, right? That line down the side of the toothbrush is where the two dies would have met up. So they would have clamped together like this, injected the plastic, and then they'd pop the toothbrush out, right? So where these pins are here is not only where the plastic would have been injected, but where the pins then come out and push the two halves apart. Oh, sorry, once the two halves are pulled apart, then these pins come out of one of the dies and pushes the part out of the other half of the mold. And which is what you're seeing here, but you can sort of see all these little grind marks over over these injection points here, which means that, they had to do quite a bit of, fixing up just there. But, I don't have to take a knife to this in order to see just how much, glass fiber is in there. It almost looks like carbon fiber. It's so, there's quite a lot of it, but, same thing with the body here, glass fiber reinforced, PA6 glass fiber 30%. I do like this little bit here though, because one of these is a machine screw and they've got a little brass, little threaded doodad just there. I do like that little addition, nice little thought, but you can sort of see the spade connectors here are quite a bit thinner. The wire is a little bit thinner. There's no heat shrinking here. It's just kind of crimped together. Sort of these wires here, they're all just kind of soldered into place. There's no sort of spade connectors, but this whole board here, from both sides, if you can sort of see just down the sides there, is not epoxied in the slightest, but you can sort of see like this board here has got, it's, this, it looks like it's been sitting like a really dank, damp warehouse. And actually, if I take this screw off just here, you can, the board is cracked right where this screw is in. So whoever was putting this in had a bad day. That they don't get paid to care. That board there is cracked right there. If there was any kind of trace that ran anywhere near there, this tool would have been ready for the scrap almost for the minute it left the factory. It would have been ready for scrap. Really should. I want to put a washer on it here, but I don't really want that washer to sort of, intrude with anything. But you can kind of see like these brushes here, it's just the carbon block. There's no copper braiding that's sort of coming off of here. It's just that spring has almost no tension in there at all. It's just, but there's no copper braiding comes out of here. There's that brush housing it's plastic. It's decently strong plastic. I've used this for a few hours. When I first bought it, I'd sort of thought, I'm going to put it to its ringers, and used it for a few hours, just, sanding and cutting and grinding and all those other things. And so, from what I could understand, this plastic here is what does Ave call it? A thermoset plastic. It's not going to melt anytime soon, that's for sure. Because if it was going to melt, it would have. And I did take this apart when I first got this, in order to sort of see, because I'm curious, I get something, I want to take it apart, you know. I want to see how it works. I want to see how it's built, you know. And I would sort of go a little bit more into detail about, well, what I can do actually. I can take one of these brush housings off of here, because that there is just held in there with a little screw. Not a little screw, it's bigger than the ones on the Xceed, that's for sure, but the way it's kind of designed, it's almost as though the brush housing is, yep, yeah, so there's your brush just there. It's just a carbon brush. It's interesting because in the Xceed tool you can kind of see that these little inclusions in it, I think they're bronze or something, but the brush isn't 100% carbon. It's interesting. It's a better quality brush, but this brush here, I mean, it's fine. It's a brush, I guess, but actually one of the things that I will do is there's actually a little tab here on this brush holder. There isn't any markings on here to actually tell what it's made out of, but there's an A there. But you know, you can kind of see, or maybe you can't, but you know, where the carbon is sort of, you know, kind of created this little dust. But you know, that brush housing, you know, that little spade connector, nothing in comparison to the other one. If I get my little calipers here, it is literally point two 0.25, a quarter of a millimeter. It is literally 1/4 the material of the Xceed. In 10 years we've lost 3/4 of the material. Well, that happens. This was the screw. Yep, okay, that was the screw. So if I want to get this back in, I've got to go like this. That was the screw. This was the screwdriver. Let's see. The brush. See, you got to actually kind of pull the spring back even further in order to get the brush in there, and of course the brush just drops in there. Then you just kind of pull the spring back, snaps in place, sits in there nice and snug. Nice and snug. Snug as a bug in a rug. Alright, and yeah. You've got like a little doodad just there. I'm guessing that there's just a controller for the potentiometer just there. I mean, the board pretty well looks very similar to, I mean, there's no likelihood that the board in the Xceed is exactly the same. It's just been potted. But I like the fact that they did, you know, actually, why am I sitting here trying to question? It's sitting right in front of me. We can have a look at it right now. Just, for a second there I thought it was magnetic. I hope it's not. That would suck. Magnetic screws around an electrical, around a PCB. Ugh. It's frightening. And hopefully we can just kind of pick that up. Will it pick up? Ah, there we go. Okay. Yeah, no, it's very basic circuit board. You've got same thing. You've got like a little on and off switch just there. There's like a resistor and there's a capacitor. The resistor here. You've got your potentiometer, which is sort of. I don't like the fact that it's indexed. I wonder. Similar thing is, big uh, capacitor, or maybe that's a what's the word I'm thinking of? Because you see these in I'm trying to think squirrel cage fan motors all the time, but this isn't a squirrel cage motor. This is a brushed universal motor. It can run in both AC and DC, so you can sort of see, these points here. You can sort of see all the electrical sort of running into the. It's not a permanent magnet motor. Long story short, but really basic boards. You can sort of see like all these staining and stuff. Like it was sitting in a warehouse for a long time before it was ever thrown onto this tool. I just got to figure out how to actually get it back in there, because it's okay. Yep. That there is the screw to go on here. Really should think of a way in order to try and repair that. Because I'm thinking maybe just like if I had like a acrylic washer, maybe something, a non-conductive washer. I'm thinking like a hard plastic. What could I use? Maybe some of that clamshell packaging. If I got some of that and sort of glued a couple of them together, so I had like, several of that thick, so it's not as flexible. You don't have that much flexion to actually give a good purchase on there, because that's just weird. And then of course to put it back together, that there just kind of, it doesn't actually, there, just kind of slips on there, no problem. Machine screw, in the top here, and then of course our two screws down the bottom, one and two. I'm sorry if I'm talking really quietly. I'm not very good at these kinds of, and I'm really sorry if it was a partial tear down, but you get the basic idea of the rest of it. It's pretty. They're basically sort of like the motors and all that stuff is relatively the same. But I do want to go into the tooling on both of these. Actually, tell you what, I'll do that in another video. I hope you liked watching this. Sorry if I'm so boring, but and sorry for the bad camera angles and all that jazz. I'm trying my best to try and get everything within the camera angle, but it's not as easy. And I'm sure that this kind of thing would come naturally for some people, but for me it's sort of like I'm just kind of ad-libbing here. Like I don't have any scripts or anything. I'm just I've made like maybe like half dozen videos trying to sort of elucidate my sort of my thing on this, my thoughts on this, and I'm sure somebody else has. I'm sure they've done it. I'm sure people have done this a dozen times, like complaining about the changing the interface and the complications with adapters and trying to find a different attachments to marry up with these interfaces. But we'll get into that in the next video, because I want to talk about these adapters and whether or not that you should invest in them, or if you should just invest in a new tool. I mean, like I said, I mean, this thing is like 10 years older compared to this one, but if you're like, yeah, you know, I want to get my new, like, I want to get a new multi-tool, but I'm not entirely sure whether or not I should. I'll go into that a little bit in the next video. So, see ya.